In this lecture, we will extend node voltage analysis to the circuit with dependent sources. This is rather simple. When a circuit contains a dependent source, for instance here we have the dependent source here, the controlling current, in this case Ix, or voltage of that dependent source must be expressed as a function of the node voltages. In other words, if we were to have here VA and VB, we would define Ix, the controlling current, as VA minus VB divided by 6. Let us understand this concept by solving an example. Here I will start by defining the node voltages. Here I have VA, here I have VB, and here I have VC. But VA is trivial, it's equal to 8 volts because between the node A and the reference node here we have this 8 volt resistor. So it's 8. Now let us try to write Ix. Ix will be equal to 8 minus VB divided by 6. So now I know this controlling voltage, controlling current, and accordingly VC will be equal to 3 times Ix, 4 minus VB over 2. And as the last step, I need to find the Kirchhoff's current law for this node B. This current is going out, this current is going out, this is entering. So VB minus 8 divided by 6 plus VB minus 4 plus VB over 2 divided by 3 is equal to 2. Let's simplify this a bit and see what happens. VB minus 8 plus 2VB minus 8 plus VB is equal to 12. I have 4VB is equal to 28. From here I find VB as 7 volts. I have VA, I have VB, now I need to find VC. In order to find VC, I will use this equation. VC is equal to 4 minus 7 over 2, which is equal to 0.5 volts. And in addition, let us also find the controlling current Ix. Ix will be equal to 8 minus VB over 6, and I know VB, which is 7, so therefore Ix will be 1 over 6 amperes. So I determined all the node voltages. In addition, I found the controlling current. We finished the analysis of this circuit. Okay, here is another example. This looks kind of hard. We have here Vx, which is related to VA. So let me again start by defining my node voltages. Here I have VA and here I have VB. But VA is equal to minus Vx. And I have actually here a super node, because in between I have a dependent voltage source. So what is this voltage source? Minus Vx minus VB is equal to 4Vx. And accordingly I have minus VB is equal to 5Vx. This is the first equation I can write. Now let us try to write the Kirchhoff's current law for this node. So 3 amperes is entering, this current is going out, and this current is going out. VA, which is minus Vx divided by 4 plus VB over 10, these are the currents going out, is equal to 3. Let's simplify this a bit, and I will write minus 5Vx plus 2VB is equal to 60. And I will put wherever I see VB minus 5Vx. And accordingly, this will become minus 5Vx plus 2 times minus 5Vx is equal to 60. And I end up with minus 15 Vx is equal to 60. Vx is equal to minus 4 volts. And if Vx is equal to minus 4 volts, Va is equal to 4 volts, one of my node voltages. And Vb will be equal to, from this equation here, minus 5Vx and accordingly 20 volts. So this way I found both Va and Vb and concluded my circuit analysis. I need to determine the node voltages of the circuit, and indeed I see only one node, Vb here. And I have a current IA which controls the current dependent current source, and the function of the current source is 5 times IA. Indeed, I have the current IA flowing into the node VB and also 5 times IA flowing in it. Therefore, over the 2 kilo ohm resistor, I will have 6 times IA. So accordingly, I can write VB over 2 kilo ohms is equal to 6 times IA. And from here, I can calculate IA as VB over 12 kilo ohms. So this is an important equation. That's one. Then I can write IA as the current flowing from minus 2 volts to VB over the 4 kilo ohm resistor. 2 minus VB divided by 4 kilo ohms is IA, and this is my second equation. I can write 1 is equal to 2, and that will be VB over 12 kilo ohms is equal to 2 minus VB divided by 4 kilo ohms. Accordingly, I have VB is equal to 6 minus 3 VB, and from here I will calculate VB as 1.5 volts, and I found the only node voltage in my circuit. If I want to find IA, I need to divide VB by 12 kilo ohms. So this will be equal to 1.5 volts times 12 times 10 to the power of 3 ohms, and it will be accordingly 0.125 milliamperes. Okay, I can simply calculate IA as V1 minus V3 divided by 4 ohms. So V1 is 10 volts, V3 is, so it is minus 2 volts divided by 4 ohms and is equal to minus 0.5 amperes. Easy peasy. Now, how can I calculate the R? So I have here V3, I have here V2. V3 times V2, V3 minus V2 is equal to R times IA. V3 is 12, V2 is 14, and I have here R and minus 0.5. So accordingly, minus 2 is equal to minus R over 2, and from here this becomes plus, this becomes plus, R is equal to 4. I found this R. Now this is slightly harder. How will I find IB? So let's assume that I have a super node here. So this super node, this current is entering, a current is getting out this way, and we have IA entering and IB going out. So what is entering to this node? IA plus 1 over 2 is entering, and what is going out is IB plus V2 minus V1 divided by 2. So V2 is 14, V1 is 10. So I can write this as minus 0.5 plus 0.5 is equal to IB plus 2. So accordingly, I calculate IB is equal to minus 2 amperes. So the question is solved.